Hello and welcome again to Pros and Experts. Let's start solving the next question. Mathematically, explain how DTFT is related with Z transform. So this is a theory question, and I don't suppose you need my very deep help in solving this. Anyway, I will spit out the essentials of this question. The question asked is relate DTFT with Z transform. Okay, let me start a mouthful with the Z transform. Z transform is given by for a signal x of n, it is defined as x of z is equal to sigma over n equal to minus infinity to plus infinity x of n into z raised to minus n. This is the Z transform of the discrete time signal x of n expressed by x of z. Okay, so the special guy is nothing but our z. Z is the special guy, whom I can write it as z is a complex number. Z is a complex number because it is a complex frequency, complex digital frequency. So z should be a complex number, and I am writing z as r e raised to j omega. Z equal to r e raised to j omega, which is nothing but the polar form of that complex number. And we have already seen another representation of a complex number like a plus jb. Okay, a plus jb, that is called a rectangular form of representation of a complex number. But this thing, z equal to r raised to j omega, is the polar form where magnitude of the complex function is r and phase angle of the complex number is omega. Okay, so now let me give a little intuition about z on a geometrical perspective. Okay, let this be the z plane. This axis is the real part of z and this is the imaginary part of z. Okay, now let me choose a vector. Let me choose a vector in the z plane like this. Okay, and if this is a complex plane, so definitely this vector is a complex number. This vector represents a complex number. And what will be the length of this complex number? What is it? If z is this complex number, then the length is same as magnitude, that is r. So I can write here as r. R is the length of the vector or magnitude of the vector. And my next question is obviously, what is the phase angle of this vector? Phase angle means it is the angle measured in the counterclockwise direction from the x-axis. That means this angle. What can it be? Of course, your answers are right. It is omega. Okay, so because this representation is like that, r is the magnitude, omega is the phase angle of this complex number. So I'm representing z in the z plane as r e raised to j omega. So omega is this angle. Okay, so now what I'm asking you to do is have an imagination where this vector is lying on the x-axis like this. Okay, like this. Okay, with magnitude r, and phase angle now is 0. Okay, now what I'm going to ask you is, imagine that you are keeping r as a constant and vary omega equal to 0 to 2 pi. Okay, now vector is in this position. That means this length is r and the phase angle is 0. Now what I'm going to ask you is to keep r constant and vary omega from 0 to 2 pi. What will you get? Omega equal to 0. You vary omega in the counterclockwise direction, so it goes like this, becomes 90 degree, then goes like this, becomes 190 degree, then 270 degree, and finally to 2 pi. What you get is a circle. Obviously, this is a circle. Okay, this is what I intended. I kept r as a constant and rotated or changed omega from 0 to 2 pi so that I got a circle in this z plane. Okay, now what if I if I keep my r as equal to 1, I'm keeping r equal to constant, and that is equal to 1, r equal to 1. What happens? This will be still a circle, but I can call the circle as a unit circle, right? This is a unit circle because its radius is equal to 1. Okay, so I can write this as a unit circle. This is a unit circle in the z plane. This is very important. Okay, and the center of this unit circle is at origin of the z plane. So this is a little intuition I can give you about the complex number z, or the digital complex frequency z. Okay, and now so save these ideas, okay, save these concepts, because now I'm going to play around with some mathematics, some simple mathematics. What it is, I can write, because the question is actually the relation between DTFT and Z transform. So I have to, at some particular point, I have to consider DTFT. So at this point, I'm writing the expression for DTFT of a signal x of n, which is given by x of e raised to j omega is equal to sigma over n equal to minus infinity to plus infinity, the signal x of n into e raised to minus j omega n. This is the expression for DTFT of a signal. Okay, and parallelly, I am once again writing the expression for Z transform. X of Z is equal to sigma n equal to minus infinity to plus infinity. We have already this equation here. I'm going to run once again into x of n z raised to minus n. Okay, and now what I'm going to do is, I'm continuing the Z transform equation here. What happens to this equation when we apply the condition we have taken? The condition we have taken is nothing but Z equal to r e raised to j omega, right? R is kept as 1. Okay, r is kept as 1. Right, omega we read from 0 to 2 pi, just to make you understand that this is a unit circle here. But what happens when r is equal to 1? Let me tell you. X of z is equal to sigma n equal to minus infinity to plus infinity. X of n into z is actually r e raised to j omega. R e raised to j omega whole raised to minus n. This equation directly changes to this equation when I put z equal to r e raised to j omega. Okay, I have put z as r e raised to j omega, nothing else. Okay, now this becomes equal to, when I apply r is equal to 1, x of z reduces to sigma over n equal to minus infinity to plus infinity. X of n into r is 1, r is equal to 1. So 1 raised to minus n into e raised to j omega to the power minus n becomes e raised to minus j omega n. Okay, so have you seen this equation anywhere else? Yes, of course. This is right near us. This is the equation for DTFT, nothing but DTFT. Okay, so I can write this equation as DTFT x of e raised to j omega. So what magic happened? If you think, you can very well know that the Z transform, we started with Z transform, right? We started with Z transform and ended up with DTFT. So I can tell you that Z transform reduces to DTFT when this condition r is equal to 1. R is equal to 1 means mod z equal to 1, right? Mod z is nothing but r. Z is written as a complex number in polar form, so r represents the modulus. So r equal to 1 means modulus of z equal to 1. So I can write Z transform reduces to DTFT when mod is equal to 1, or in other ways, this is very important, or in other words, I can write DTFT is equivalent to Z transform evaluated along the unit circle. Okay, the special case of mod is equal to 1 or r equal to 1, all is geometrically a unit circle. Okay, all is a unit circle. So DTFT is nothing but Z transform evaluated along this unit circle. This makes quite sense because as you know, Z transform deals with complex frequencies, right? Z transform deals with complex frequencies, but DTFT only deals with real frequencies. So actually this plane is entirely Z plane, but only a portion, this unit circle alone reduces or alone stands for DTFT. Like that, complex frequency is a superset and real frequency is only a subset. Okay, so out of this complex superset, the real frequency exists only along this unit circle. So that's the sense of this answer. This is a very important concept. Okay. So this is the ultimate relation between Z transform and DTFT. DTFT is same as Z transform evaluated along the unit circle. Okay. Okay, the next question is, show that the Fourier transform of the signal x of n equal to sine pi n by 2 u of n is given by x of e raised to j omega equal to e raised to minus j omega by 1 plus e raised to minus j omega. So given signal is x of n equal to sine n pi by 2 into u of n. So straight away we don't have any equation relation that gives the Fourier transform of this discrete time signal. So either we have to start from the scratch, use the basic equation and derive the Fourier transform. That is obviously possible, but it requires allotment steps. So I think I will be going to depend upon the properties of discrete time Fourier transform. So before applying the properties, let me have a basics. Let me tell you some basics. That is, for a signal x of n equal to a raised to n u of n, the Fourier transform x of e raised to j omega is equal to 1 by 1 minus a e raised to minus j omega. So this is a standard result we can depend upon. Okay, now if at all I am taking a signal as x of n equal to u of n, what is the Fourier transform of x of n equal to u of n? X of n equal to u of n is nothing but x of n equal to 1 raised to n into u of n, and now we can relate this equation with the standard form. Okay, so in this case x of e raised to j omega will be equal to 1 by 1 minus a is 1, so e raised to minus j omega itself. Okay, so this is a takeaway from this question. Now given x of n is not just u of n but sine pi n by 2 into u of n, sine pi by 2 n into u of n. Okay, but we know sine pi by 2 n can be written as e raised to j pi by 2 n minus e raised to minus j pi by 2 n whole divided by 2j, whole divided by 2j. Okay, whole divided by 2j is distributed among the two terms into u of n. Okay, this is sine pi n by 2 into u of n. Okay, instead of pi n by 2 we have this Euler's equation. Okay, we have seen that many times, because cos theta equal to e raised to j theta plus e raised to minus j theta. Then sine theta is equal to e raised to j theta minus e raised to minus j theta, divided by 2 here. This is 2 cos theta, this is 2j sine theta. So from this equation we can write like this. Okay, sine theta is written like this. Okay, so let's continue with this question. This expression, this is actually 1 by 2j. I can take 1 by 2j outside into 1 raised to n into e raised to j pi by 2 n u of n. Okay, minus again 1 raised to n e raised to minus j pi by 2 n into u of n. Okay, I have just elaborated the same equation. Okay, then so this is my x of n. Okay, now I have to write x of e raised to j omega, right? Therefore x of e raised to j omega equal to 1 by 2j into, what is the Fourier transform of this term alone? This term alone, that could be you have to listen here, for x of n equal to 1 raised to n u of n or simply u of n, x of e raised to j omega is this thing, 1 by 1 minus e raised to minus j omega. But here, you know, instead of 1 raised to n u of n, the signal is actually e raised to something, e raised to jn pi by 2 into u of n, into u of n. So what should be the Fourier transform of this thing? It should be, what property can you use? This is nothing but, you can see that the time domain is multiplied by exponential signal. Time domain multiplied by exponential. So what does it make to the frequency domain? Shifting happens, right? Okay, shifting happens. So whenever time domain is multiplied by exponential, frequency shifting happens. So we can write it as x of e raised to j into omega minus pi by 2. Okay, here it is pi by 2 shift, pi by 2. Okay, so I can write the Fourier transform of this term as, instead of 1 by 1 minus e raised to minus j omega, as you can see in this relation, we have to shift the frequency. So omega becomes omega minus pi by 2. Okay, that is the first term. Minus second term. We can see second term also contains 1 raised to n u of n, whose DTFT will be 1 by 1 minus e raised to minus j omega, but there is an extra multiplication of e raised to minus j pi by 2n in the time domain that results again in frequency shift, like this. Okay, so this is 1 by 1 minus e raised to minus j omega into, here you can see a minus there, so in frequency shift that will be plus, so plus pi by 2, okay, e raised to minus j omega into plus pi by 2. I mean omega minus pi by 2. Sorry, this was a mistake. Frequency shifting should be there. Okay, so it is e raised to minus j into omega replaced by omega minus omega plus pi by 2. Okay, right, now this is only a matter of simplification. So 1 by 2j into, we can find the LCM by cross multiplying this term to numerator and this term to this numerator and taking the product of the denominator, and you will get 1 minus e raised to minus j into omega plus pi by 2 minus of 1 minus e raised to minus j into omega minus pi by 2 whole divided by 1 minus e raised to minus j into omega minus pi by 2 into 1 minus e raised to minus j into omega plus pi by 2. Okay, so this happens to be 1 by 2j into, I can write this as 1 minus e raised to minus j omega into e raised to minus j pi by 2. Okay, minus 1 plus e raised to minus j omega into e raised to plus j pi by 2. I have just split this exponent into e raised to minus j omega into e raised to minus j pi by 2. Here also split this into e raised to minus j omega into e raised to minus pi by 2, that is e raised to plus j pi by 2. I hope that is clear. Whole divided by, now I am multiplying this term and this term, so this becomes 1 minus e raised to minus j omega. Again I can split this exponential into e raised to minus j omega into e raised to plus j pi by 2. Okay, minus e raised to minus j omega into e raised to minus j pi by 2 plus e raised to minus j omega into e raised to plus j pi by 2 into e raised to minus j omega into e raised to minus j pi by 2. Okay, so what I have done is first term into first term, so 1, then this term into this term, you got it as this term, then this term into this term, you got it as the third term, third term, this one, and finally this term with this term, so plus this last term. Okay, So readily we can cancel 1 minus 1. Then okay, here we can have a e raised to j pi by 2 and e raised to minus j pi by 2. They will cancel to give 1 and nothing else. Okay, now again we can simplify this as 1 by 2j into from these two terms I can take e raised to minus j omega outside. So e raised to minus j omega into e raised to minus j omega into, I am taking this first term. So e raised to minus j omega into e raised to j pi by 2 minus e raised to minus j pi by 2. Okay, whole divided by in the denominator. What I can do is it becomes 1. Okay, 1, and from these two terms I can take again e raised to minus j omega outside. So 1 minus e raised to minus j omega, I'm taking minus e raised to minus j omega outside. So into e raised to j pi by 2 plus e raised to minus j pi by 2, plus because I have taken minus e raised to minus j omega outside. Okay, plus what is the last term? Last term there was a cancellation, but still e raised to minus j omega into e raised to minus j omega, that becomes e raised to minus j2 omega. So e raised to minus j2 omega. Okay, now what I can do is, this is 1 by 2j into e raised to minus j omega into, what is e raised to j pi by 2 minus e raised to minus j pi by 2? It is nothing but 2j sin pi by 2. Okay, 2j sin pi by 2. We have already seen this Euler's theorem here, right? So this is 2j sin pi by 2. It comes from the equation e raised to j theta equal to cos theta plus j sin theta, and e raised to minus j theta equal to cos theta minus j sin theta. We can arrive from this equation. We have already seen it many times. Okay, divide by, in the denominator we can see 1 minus e raised to minus j omega into, what is inside the bracket? This is e raised to j pi by 2 plus e raised to minus j pi by 2. That is e raised to j theta plus e raised to minus j theta. Okay, if you sum it, you get 2 cos theta. Okay, it is 2 times cos theta is pi by 2 here, 2 cos pi by 2, and last term is e raised to minus j2 omega. Okay, I think we have the freedom to cancel out 2j here. So ultimately we are arriving at the answer. Final step, x of e raised to j omega equal to what is sin pi by 2? Here is a sin pi by 2. We can give it as 1. Sin pi by 2 is 1. So this is numerator is e raised to minus j omega alone, whole divided by and what is cos pi by 2? Here is the cos pi by 2. Cos pi by 2 is cos 90, which is 90 degrees. So we can cancel this term as 0. So what remains is 1 plus e raised to minus j to omega. So this is the simplified form of our discrete time Fourier transform. And that is the same expression, very same expression that we needed to prove. So this is the proof. So the next question is, find the Z transform and ROC of the following signals. We have 2 sub questions. The first one is x of n equal to a raised to mod n for mod a less than 1. Okay, and we know that a raised to mod n, we have already seen definitions for that. A raised to mod n will be equal to a raised to n for n positive greater than or equal to 0, and it is a raised to minus n for n less than 0. So we are going to make use of this definition for mod n, a raised to mod n. Okay, so let us start from the scratch. X of z, the definition for x of z is equal to sigma over n equal to minus infinity to plus infinity x of n into z raised to minus n. Okay, so while summating this x of n into z raised to minus n from minus infinity to infinity, it encounters 2 parts. One, a function a raised to n for positive n values, and the other another function a raised to minus n for negative n values. Okay, so let us split this summation accordingly. So this is sigma n equal to minus infinity to minus 1, right? Minus infinity to minus 1 in order to incorporate there's negative n values and the corresponding function. So corresponding function is a raised to minus n into 0 raised to minus n. Okay, x of n is a raised to minus n in negative n, and along with this 0 raised to minus n should be there. Okay, plus the other part of the summation is n equal to 0 to infinity. That means positive n values, where x of n will be this function a raised to n. It is for positive n values. Okay, so instead of x of n, it is a raised to n, 0 raised to minus n. Okay, right. Now what we need to do is just expand the two sigma terms separately. So here for the first value of n, it is n equal to minus 1. Okay, in n equal to minus 1, then equal to minus 2, then minus 3, and goes on to minus infinity. So I can write it as I can write somewhere else, a raised to minus of minus 1, that's a raised to plus 1, into z raised to minus of minus 1 is 0 raised to plus 1. So this is a into z. So I can write as first term as a into z, plus what is second term? Second term is a raised to minus of minus 2 into z raised to minus of minus 2. So a square z square, or I can write it as az the whole square, az the whole square, plus what will be the third term? It will be az the whole cube, and it goes up to infinity. So that is the expansion of the first sigma term. Okay, and now coming to expanding the second sigma term, it starts with n equal to 0. So substituting a raised to 0 into z raised to minus 0, you will get it as 1. Anything raised to 0 is 1. Plus now n equal to 1. N equal to 1 means you are getting a into z raised to minus 1, right? A z raised to minus 1. So you can write as a into z raised to minus 1. So what will be the result at n equal to 2? It will be a square z raised to minus 2. A square z raised to minus 2. That I can write it as a z raised to minus 1 the whole square. This is same as a square z raised to minus 2, right? The next term is a z raised to minus 1 whole cube, and it goes up to infinity terms. Okay, now we know what to do. This is an infinite GP with first term az and the common ratio az. Okay, and we know the expression to find out an infinite GP is a by 1 minus r. Sum is equal to a by 1 minus r. A is the first term, so first term is az divided by 1 minus r. What is r? It is common ratio is a into z. But in taking so, we have to assume that mod r is less than 1. So here the mod r is given by mod az is less than 1. It is needed to calculate the ROC because it is defined in the question, specified in the question. Okay, so that was for the first term. Plus what is the equivalent expression for the second term? Second term is 1 plus az inverse whole square plus etc. This is again an infinite GP with first term is 1 and common ratio as a into z inverse. So the sum is first term divided by 1 minus common ratio. Common ratio is a into z inverse. Okay, again immediately after taking the this kind of sum, we have to assume that mod of a z inverse is less than 1. Okay, and also remember that in the question it is given mod a is less than 1. Okay, we'll use it. Okay, now when I simplify it, the first term I'm dividing by minus a throughout the first term. So minus z divided by, it becomes z minus 1 by a, right? I have divided using minus 1 by a on both numerator and denominator. So we got this plus this is actually z by z minus a. We know that. Okay, 1 by 1 minus a z inverse is z by z minus a. Okay, so this is the Z transform. This is the Z transform. But what is ROC? To find ROC, we have the ROC for individual terms. One is mod AZ less than 1, or we can write it as mod z less than 1 by a, right? Mod z less than 1 by a. You have to take a to the denominator of this side. So mod z less than 1 by a. Intersection. What about this term? Mod a z inverse is less than 1 means mod a by z is less than 1, right? Mod a by z is less than 1. That means mod a is less than mod z, or we can write mod z is greater than a. Okay, mod z is greater than a. Therefore ROC is in between mod a and 1 by mod a, right? ROC is between, or I can write mod a less than z less than 1 by mod a. Okay, if there is some doubt regarding that, in the question we have to note that in the question it is given mod a less than 1. So mod a less than 1 means 1. What is 1 by a? 1 by a will be greater than 1, right? 1 by a will be greater than 1. Okay, and what I mean is 1 by a will be greater than a, right? 1 by mod a will be greater than y. So if we draw the ROC, which will be the greater pole? We have two pole, 1 by a and a. Which will be the greater pole? 1 by a will be greater, right? 1 by a will be greater because mod a is less than 1, right? For example, if mod a is equal to 1 by 2, mod a is less than 1. So what is 1 by a? 1 by a is 2. Okay, so one pole is 1 by a and the other pole is a. One pole is 1 by a and other pole is a. So this is 1 by a is greater and a is lesser. So mod z less than 1 by a means this entire circle inside to this outer circle. Okay, and mod z greater than a means this part outside to the circle corresponding to pole equal to a. Okay, so the common intersection is this central part, circular disc part. Okay, that's given as mod a less than mod a less than z less than 1 by mod a. So that is the ROC. So this is the Z transform and this is the ROC. And there is a sub question B also. Find the Z transform and ROC for y of n equal to half n square 1 by 3 to the power n minus 1 e of n minus 1. To solve this question, we need two properties of Z transform. The first property is very simple. It is time shift property. So if x of n is having a Z transform x of z, right, then x of n minus 1 will be having a Z transform z inverse x of z, or in general x of n minus n0 will be having 0 raised to minus n0 into x of z. Okay, that is time shift property. And another property you need to use is if x of n and x of z are Z transform pairs, then the Z transform of n into x of n will be minus z into d by dz of x of z. This is differentiation in frequency property. Frequency is being differentiated. Okay, so let us keep these two properties in our mind and solve this problem. Okay, so y of n is given as half n square 1 by 3 raised to n minus 1 u of n minus 1. We don't know anything. We don't know the Z transform of any factors in that expression, but let us think what we know very closely. If at all it was 1 by 3 raised to n u of n, its Z transform is familiar to us. Its Z transform is z by z minus 1 by 3. That is quite obvious, a common result. Okay, now we are slowly transforming this non result into the question result. Okay, so next I'm going to find out the Z transform of 1 by 3 raised to n minus 1 into u of n minus 1. That is simple because you need just to rely upon time shift property of Z transform. and that tells you to multiply z raised to minus 1 into with z by z minus 1 by 3, and that will equate you with 1 by z minus 1 by 3 because these two cancel. Okay, so the z transform of 1 by 3 to the power n minus 1 u of n minus 1 is just 1 by z minus 1 by 3. That is very easy. Okay, now let me take the next step as finding the Fourier transform of z transform of n into the signal, n into this whole signal, n into x of n, right? Just like n into x of n. I'm treating this as x of n, so n into x of n, n into 1 by 3 to the power n minus 1 u of n minus 1. And what will be the z transform? It is nothing but we can rely upon this property, n into x of n will give minus z into d by dz of x of z. So minus z into d by dz of, what is the Fourier transform of our x of n? X of n in this equation, it is x of z 1 by z minus 1 by 3. So x of z is 1 by z minus 1 by 3, which we can simplify as minus z into minus 1 by z minus 1 by 3 the whole square, or it is plus z by z minus 1 by 3 square. Okay, now think, is it that what we want? We got a signal and we got a z transform, but is it that the question asks us to find out? No, but we are very close. We are very close. What we need to find out is half n square into something, right? Half n square. So what I'm going to do is I'm going to multiply again n into 1 by 3 raised to n minus 1 u of n minus 1, and going to find out the z transform of this one. Again we can use the same property, differentiation in frequency property, because this is of the form n into some x of n, and for this x of n, you know the z transform is this thing, z by z minus 1 by 3 square. Okay, so again I can apply minus z into d by dz of, this time x of z is this thing. Okay, so that is z by z minus 1 by 3 square. Okay, so what will be the answer? It is equal to, I can elaborate it, minus z into denominator into differential of numerator minus numerator into differential of denominator. It is 2 into z minus 1 by 3 to the power 1. Okay, whole divide by we have to find the square of the denominator, z minus 1 by 3 to the power 4. Okay, so on simplification this becomes minus z into z minus 1 by 3 square minus 2z into z minus 1 by 3 whole divided by z minus 1 by 3 to the power 4, and obviously we can cancel out 1 z minus 1 by 3 on numerator and denominator, and that will give you minus z into z minus 1 by 3, sorry, z minus 1 by 3 is already cancelled. Okay, z minus 1 by 3, one power is only just alone cancelled, so z minus 1 by 3 minus 2z whole divided by z minus 1 by 3. Again we can simplify it as the z minus 2z is minus z, so minus z minus 1 by 3. Okay, this is equal to minus z into minus z minus 1 by 3, but this minus can be taken out, becomes plus, so all of this becomes plus, divided by z minus 1 by 3. Okay, so ultimately the z transform we obtain is equal to z into z plus 1 by 3 divided by z minus 1 by 3. Okay, so remember this is the z transform of this thing. This things means this is nothing but n square into 1 by 3 to the power n minus 1 u of n minus 7. And is that the question? Is that the question demands us to find out? No, it is half into n square. A half is alone missing. Half alone is missing, and that is very obvious. Therefore, according to linearity, half n square 1 by 3 raised to n minus 1 u of n minus 1 will give us the transform of half into z plus 1 by 3 divided by z minus 1 by 3. So this is the ultimate final answer for Z transform. And what is ROC? Oh, one second. There's a slight mistake, a very careless mistake, because here it is 4, right? Here we have cancelled only 1 z minus 1 by 3, okay? That means z minus 1 by 3 to the cube remaining, right? To 3 will be remaining. So here alone, here also cube will be remaining, right? Okay, only 1 z minus 1 by 3 was cancelled, so z minus 1 by 3 cube will be remaining. Okay, so what is the ROC then? In the denominator we have only z minus 1 by 3, so z equal to 1 by 3 is the pole, and we can see the question is the entire signal is right sided, right? Half n square into 1 by 3 raised to n minus 1 u of n minus 1 is entirely right sided, so the ROC becomes mod z greater than 1 by 3. Or all the right sided signals will be having an ROC outer to the outermost pole. Here the pole is 1 by 3, so outer to the circle representing the outermost pole, so mod z greater than 1 by 3. So that's the answer.